Hello students, today we are going to solve some more examples on gamma functions from the exercise. First, let's prove that y gamma 0 equals to infinity. As we always say that when gamma n is integral from 0 to infinity e power minus x to the power n minus 1 dx, and n is always greater than 0. So what happens when n is 0 or it is negative? So let's start from 0. So by the properties of gamma function, we studied that gamma n plus 1 is equal to n times gamma n, or we can also write it as gamma n is equal to gamma n plus 1 upon n. So when n is equal to 0, so what happens? Gamma 0 is equal to 0 plus 1 upon 0, and that is gamma 0 is equal to gamma 1 upon 0, and gamma 1 of course is 1 upon 0, and 1 upon 0 is infinity. So gamma function at 0 approaches to infinity. Similarly, for n is equal to negative 1, so again we have gamma n is equal to gamma n plus 1 upon n. So for n is equal to minus 1, gamma minus 1 is equal to gamma minus 1 plus 1 upon minus 1. So this will be gamma minus 1 is equal to gamma 0 upon minus 1, and gamma 0 is infinity, which is infinity. Similarly, for n is equal to minus 2, so it will be gamma minus 2 is equal to minus 2 plus 1 upon minus 2, and this will be gamma minus 1 upon minus 2, and gamma minus 1 is infinity. So again gamma minus 2 is infinity. Another example from the exercise is to evaluate integral 0 to 1 dx upon minus log of x square root. So let I is equal to integral 0 to 1 dx upon negative log of x under root. Let this is equation number first. So first let's make a supposition. Put negative log of x is equal to, let's suppose, t. Then by the properties of log, we know that log of negative x, this negative sign will go here. This will be log of x to the power minus 1. This will be equal to t. To remove the log, we use exponential, so x inverse will be equal to e to the power t, or 1 upon x will be equal to e to the power t, and x will be equal to e to the power minus t, or you can write it as e to the 1 upon e to the power t. So as we made the substitution, and what about dx? Dx will be equal to minus e to the power minus t dt. So first, whenever there is substitution, we have to check the limits, what happens to it. So when x equals to 0, then from this equation t will be equal to When x equals to 0, then t will be equal to infinity. And similarly for the upper limit, when x is 1, then t is 0. So our new limits are from infinity to 0. So from equation number 1, I is equal to integral from infinity to 0 e to the power minus e to the power minus t dt, because we have put dx, which is minus e to the power minus t dt, and that is negative log of x is equal to t. So bring this t in the numerator, and this negative sign will change the limits. This will be integral from 0 to infinity e to the power minus t to the power negative half dt. Or we can also write it as I is equal to integral from 0 to infinity e to the power minus t to the power plus half minus 1 into dt. And you see that this is actually gamma function, and this is gamma half. Here the value of n is half, so this is gamma half, and gamma half is actually under root 5. Another question from the exercise is to evaluate the integral from 0 to infinity e to the power minus y whole to the power 1 upon n dy. Solution. So by gamma function, gamma n is equal to integral from 0 to infinity e to the power minus x to the power n minus 1 dx. Put x is equal to y to the power 1 over n. This implies that x to the power n will be equal to y, and then take the derivative of y. This will be dy will be equal to n x to the power n minus 1 dx. So put these values in the equation number 1. So again we made some substitution, so we have to check the limits. Further, we can also write this as dy upon n is equal to x to the power n minus 1 dx. So for checking the limits, as we made this substitution, when x is equal to 0, then y will be equal to 0, and when x goes to infinity, then y goes to infinity. So there will be no change in limits. So putting these values in equation number 1, this will be gamma n is equal to integral from 0 to infinity e to the power minus x, where x is y to the power minus y to the power 1 upon n, and x to the power minus n minus 1 dx is dy upon n. So bring this n out of the integral. This will be gamma n is equal to 1 upon n integral from 0 to infinity e to the power minus y to the power 1 over n dy. This n will multiply with this side. This will be n times gamma n integral from 0 to infinity e to the power minus y upon to the power 1 over n dy. or integral 0 to infinity e to the power minus y to the power 1 over n dy is equal to n times gamma n, or we can also write it as integral 0 to infinity e to the power minus y to the power 1 over n dy is equal to gamma n plus 1, as in the previous lecture, as gamma n plus 1 is equal to n times gamma n. Thank you very much.